Hi, I am Dr. Cham, and today I'm going to start a lecture series on the ECG. So we'll be covering the different portions of the ECG in separate videos so that one can find them according to their need. So this video is going to be about the basics of the ECG. We're going to discuss the conduction system of the heart, and we're going to talk a little bit about the ECG leads as well as the ECG paper. So let's start this. So the ECG or EKG, that is electrocardiogram, and that represents the electrical activity of the heart. So as far as the conduction system of the heart is concerned, in the red you can see the above the is the SA node and the below is the AV node. So SA node, that's a natural pacemaker of the heart. Okay, so the current flows from the SA node, okay, to the atria, and at the same time to the AV node. From the AV node, in the right through the bundle of his, okay, that is to then to the right bundle branch. Sorry, that's the left bundle branch, and to the right bundle branch. Okay, and in the green you can see the Purkinje fiber that has a specialized muscle cells in that the current flows through them to the ventricles. Okay, to the ventricle muscles. Now, how this is represented on the ECG, okay, when the atria contract actually, okay, the atrial contracture, that is represented in the ECG by a P wave. This is actually the atrial depolarization, okay. Atrial depolarization is the flow of the current, okay, from the SA node to the atria that leads to the atrial contraction. Then this QRS is ventricular depolarization, okay, and the T wave is ventricular repolarization. Okay, so one can ask over here that P is the ventricular, this is atrial depolarization, QRS is ventricular depolarization, and T is the ventricular repolarization. So where is the atrial repolarization? Atrial repolarization is actually that is masked by this QRS because that's big enough. When the ventricles are contracting here in the QRS, at the same time the atrias are actually relaxing. So that is masked by this QRS complex. Now, sometimes after the T wave, there is a small U wave as well. We're going to discuss each and everything separately in the different videos. Now, the P wave, then there is something else as well that is called from the start of the P wave to the start of the QRS, that is called PR interval. This is called PR interval. Let me write it over here. So it's PR interval. That's a PR interval. Okay, this PR interval actually represents the this PR interval is actually the time between the atrial depolarization and the ventricular depolarization. Actually, what happens that, okay, the atria has to contract first and then the ventricles. So whenever there's an impulse to reaches the the AV node holds the current for a fraction of a second, so that the atrias should contract first, okay, followed by the ventricular contraction. So this is actually denoted here as a PR interval. Now the next thing is, okay, from the start of the Q to the end of the T. Okay, from the start of the Q to the end of the T, this means that the time interval between the onset of the ventricular depolarization to the end of the ventricular repolarization. In other words, you can say simply, okay, this is not what exactly it is, but you can say that from the onset of ventricular contraction to the end of the ventricular relaxation, that is represented by the QT interval. So you have the QT interval over here. And then you have this portion from the S to the start of the T, that is called an ST segment. Okay, the ST segment. ST segment. So what we are having right now at the moment, we have, let me change the color so that we can appreciate it. So at the moment we have the P wave, we have the PR interval, we have this QRS, we have this T wave, we have the U wave, we have ST segment, and we have the QT interval. Okay, let me write it in a separate way that what we have at the moment, okay, and what, because this is something what we are going to discuss in our next videos. Okay, so up to now we have this P wave, we have the PR interval, we have QRS, we have T wave, we have ST segment, the QT interval, and the U wave. Okay, so this is the P wave, this is the QRS, it's a complex, it's a T wave. Okay, um, and this is what we are going to discuss in our videos. Okay, what is the P wave? Okay, and the different pathologies that are related to the P wave, and subsequently to the other like the PR interval, the QRS, and the onward. And the other things we're going to discuss is rhythm, rate, and the axis. This will comprise on our videos, and once we are done with that, okay, we're going to go to the advanced things. Now let's talk about the ECG leads. So we have the limb leads, okay, and the chest leads. Okay, these 1, 2, 3 AVR, AVF, and AVL. These are the limb leads. While we are having over here the V1 to V6. These are the chest leads. Out of these, this 1, 2, and 3. These are bipolar limb leads, while the AVR, A means augmented. So AVR, AVF, and AVL, these are the unipolar limb leads. Okay, let's now talk about the ECG paper. So this is how an ECG paper look like. Here you can see that there are the large boxes, and within the large boxes there are the small boxes. So in every large box there are the 5 horizontal small boxes and the 5 vertical small boxes. You can appreciate it over here. Okay, so horizontally, okay, every small box, that is 0.04 second. Okay, and in a large box there are those 5 small boxes. So if you're going to multiply this 0.04 with 5, okay, so that's going to be 0.2 seconds. So every large box is 0.2 seconds, every small box is 0.04 second, and every large box, that is 0.2 seconds. That is 0.04, one small box multiplied by the 5, okay, that are in the large boxes. That's equal to 0.2. And vertically, that is 1 mm. And standard ECG, that is run at the speed of 25 mm per second. So this is how an ECG paper look like. The next video of ours, we're going to discuss about the P wave, okay, and its pathologies, and the PR interval as well.